This is our first lesson in Unit 3, Parallel and Perpendicular Lines. And this lesson is on lines and angles, and we're going to start with a little terminology that you probably already know. So here goes. What kind of lines are coplanar and do not intersect? Parallel. So the key thing that you need to remember here is that for lines to be classified as parallel, they have to be coplanar. All right, if we have lines that are not coplanar, not parallel, and they do not intersect, we call those skew lines. We talked about that last week, and I think most of you were familiar with that term already. All right, and if we have planes that do not intersect, then they would have to be parallel planes. So let's look at this figure that we have here and assume that all these surfaces are actually planes, even though it looks like a cube. Let's assume that they're planes. So it says use the figure to answer the questions. Number 1, list 2 pairs of parallel planes. All right, planes that do not intersect. So, oh, I'm sorry, number 1 says lines. 2 pairs of parallel lines. Well, there are a lot of sets of parallel lines here. I'm just going to pick 2 sets. First, I'm going to pick line AD, and I'm going to say that's parallel. This is the symbol for parallel. So AD would be parallel to line BC, because remember, for lines to be parallel, they have to be coplanar. And then I'm just going to grab 2 others. How about AE? What if I pick this one right here? Line AE would have to be parallel to line BF. That's a line. Okay, so there are others, but it just says pick 2 pairs, so that's what I did. Okay, how about a pair of skewed lines? So skewed lines, remember, are going to be non-coplanar, non-intersecting. So how about if I pick line DH? Line DH. Can you think of a line there? Can you identify a line that would be skew with DH? Let me highlight DH. Here's DH right here. How about BC? That would definitely be skew, not coplanar, never intersecting. So I'm going to say DH and BC. Are there others? Of course there are. You're welcome to try to find them. All right, and finally it says name 1 pair of parallel planes. And of course we've got we've got several pairs of parallel planes. So I just wrote down plane ADHE, and I said that's parallel to plane BCGF. Okay, parallel lines and planes. Let me fix that there so it doesn't look like a P. That's a D. All right. So now, a line that intersects 2 or more coplanar lines. So in this figure, here are my coplanar lines, L and M. And this line that intersects those 2 coplanar lines is called a transversal. Intersects 2 or more, and I just have 2 lines here that the transversal is intersecting. There could be more, and it intersects these 2 lines at 2 distinct points. So there are my points, and the diagram shows that you have 8 angles formed by the transversal and these 2 lines, and those angles are numbered. All right, and we can see this area here that's highlighted in yellow, all those angles in there on the inside of those lines that are not the transversal would be the interior angles, and then the angles that are on the other side, the outsides of those 2 lines, would be exterior angles. So now we're going to name those interior and exterior angles a little more specifically. So the 2 angles that lie on the same side of the transversal and in corresponding positions, of course, first you got to think about what does corresponding mean, but I'll show you right here. Same side of the transversal and in corresponding positions are called corresponding angles, appropriately enough. corresponding angles. So let's get the corresponding angles from our picture here. Okay, same side of the transversal, so let me start on the left. Let me highlight my transversal in red here so we don't get confused at all. There's my transversal. So let's look at the left. So if I start with angle 8, the angle that's in a corresponding position, see, angle 8 here is below the line. So the angle that's on the left of the transversal and below the line is angle 4. So we got angle 4 and angle 8. All right. And also on the left side, we would have angle 1 and angle 5. And then if I go to the right side of the transversal, I'm going to have angle 2 and angle 6, and also angle 3 and angle 7. So all those are sets of corresponding angles. Alrighty, what if we have non-adjacent exterior angles that lie on opposite sides of the transversal? We call those alternate exterior angles. Alright, and the ones we can see in our diagram above, alternate exterior angles would be angle 1 and angle 7. So on different sides of the transversal, and then also I would have angle 2 and angle 8, right? Angle 2 and angle 8. All right, so there are my alternate exterior angles. Now, non-adjacent interior angles that lie on opposite sides of the transversal, of course, are called alternate. Not alternating. I hear a lot of students say that. Not alternating, but alternate interior angles. And if we look at our figure, the alternate interior angles would have to be 4 and 6. The pairs, they have to come in pairs, 4 and 6, and 5 and 3. So let's write those down. Angle 4 and angle 6, angle 5 and angle 3. All right, so there are my pairs. Oh, I've got one more set. Interior angles that lie on the same side of the transversal. So let me, since my picture keeps going out, let me do this. What does this actually look like? I'm going to move it down. Okay, a little bit different. Draw myself another picture so I don't have to keep going up and down. And my transversal. So I got 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, 7, 8. All right, so interior angles that lie on the same side of the transversal are called consecutive interior angles or same side interior angles. Okay, so the examples that we would have in the picture here would be 4 and 5. That would be a pair, right? They're on the same side of the transversal, consecutive. So we'd have angle 4 and angle 5, and the other pair would be angle 3 and angle 6. Okay, so we got to get familiar with those different types of angle pairs created by two lines being cut by a transversal. Okay, let's see what we have now. So let's look at this figure we have and think of each line segment in the diagram as part of a line. Which of the line appears to fit the description? Okay, so let's see. Parallel to AG, here's AG. You may need some colored pencils. No, not may, definitely. You will definitely benefit from having some colored pencils in this unit. So let's see, parallel to AG and contains C. So parallel, remember, it's got to be coplanar. So here's point C right here. So I'm going to say it's got to be this line, right? And you're thinking, but wait, there's no plane. Remember, any three non-coplanar points, non-collinear points make a plane. So there is actually a plane that contains all these points here. So I'm going to say line CI is parallel to AG. All right. Now I need a line that's perpendicular to AG. So there's AG and contains point B. Here's point B, so it's going to have to be AB, right? So that's going to be line AB. That makes a 90-degree angle right there. Line AB. All right, finally I need skew to AG and contains C. So here's point C. So I'm just going to say line, I could say BC, I could say CD. So I'll just pick line BC. BC is skew to AG. And finally, name the plane that contains point C. Let me erase a little bit of this. Contains point C right there and appears to be parallel to plane AFL. Where is plane AF? Plane AFL is this one on the side over here. So the plane that would contain point C and be parallel to that one is going to have to be this one right here. And I'm going to name mine with 3 letters, CDIJ. I guess I could just use 3 letters like they did, but I'm going to use 4 just to be certain and call it plane CDIJ. Okay, so there's some parallel planes and lines. Now we've got some practice problems. So that's really about it for this lesson. So I would like you to pause right here and go ahead and work the rest of the problems on this page. And then let me go ahead and show you. You're going to there's 4, so 8. So you've really just got 8 questions to answer. And then when you look on the next page, we have a proof. And it turns out, I'm not sure how this proof got in this lesson because it really has nothing to do with parallel lines or alternate interior angles, but alas, it's never a bad day to do a proof about angles. So I want you to give this proof a try. It's a short little proof, and then we'll go over it at the very beginning of class. Okay, so go back to the problems, the rest of the problems on this page, pause the video, answer these, and then come back and I'll have the answers for you. Alrighty, here are the answers I came up with. Please check your answers against these. I do want to tell you something that might come in handy for you in addition to having some colored pencils. I oftentimes find that having the 2 lines intersect kind of throws me off, and it might kind of throw you off too. And if it does, feel free to redraw. There's my transversal. I'll draw my 2 lines, only this time I'm going to draw them not intersecting. So if you do that, you might find that it's a little easier to identify your angle paratypes. 5, 6, 4, 3, 8, 7. And the fact that these 2 intersect here might not bother you at all, but sometimes when you have more than one set of lines and more than one possible transversal, you might just find it way easier to break some of those lines out and draw them separately. So that's a thought for you. And there are those answers. Please check those. Make a note over here on the side if you have any questions, and we'll talk about it next time. Don't forget to do the proof over here. I'm going to tell you it took me only 4 steps. So give it a try. Let's see what you come up with, and we'll see you next time.